Hello everyone. Today we shall see about capacitor. Capacitors are originally known as condenser. A capacitor is a storage device for electric charge and electrical energy. It is a passive electronic component with two terminals. The passive component is it does not generate energy, but it is able to store energy from an energy source like a battery or another charged capacitor. The device used to store a electric charge in an electric field and release it when it is required. It consists of two conducting objects separated by a dielectric material, that is insulator. The dielectric material is an insulator, therefore no current flows through the capacitor. The capacitor is represented by the symbol. So the conducting objects, usually plates or sheets. The conductors can be thin films, foils or cindered beads of metal or conductive electrolyte, etc. A dielectric can be glass, ceramic, plastic film, air, vacuum, paper, mica, oxide layer, etc. The capacitors can be connected in series or parallel in circuits just like resistors. This is various types of capacitors. Next, how a capacitor works inside. The simplest type of capacitor is called a parallel plate capacitor. The parallel plate capacitor is made up of two conductive metal plates that are close together with an insulating plate in between to keep the charges. The wires conduct charges coming in and out of the capacitor. So, when a battery is connected across a capacitor, one surface hits positive end of the battery and another surface hits negative end of the battery. So, when you connect a capacitor to a battery, here's what happens. The full of voltage of that battery is applied across that capacitor. The current from the battery tries to flow through this capacitor from its positive plate to negative plate. The positive plate will accumulate positive charge from the battery. The negative plate will accumulate negative charge from negative end of the battery. In the situation, the maximum amount of charge can stay there for a long time. Suppose after removing this battery from this capacitor, these two plates will hold positive and negative charges with respect to a certain voltage level for a long time. So, this capacitor acts as energy source. If two ends get shorted through a load, a current will flow through this load up to all charges get vanished. This time is known as discharging time of the capacitor. So we know that a capacitor can be charged by connecting it to a battery or any other source of current. A capacitor can be discharged by connecting it to any closed circuit that allows current to flow. The amount of charge a capacitor can store depends on several factors. First one, the voltage applied to the capacitor. Second one, the insulating ability of the material between the positive and negative plates. Third one, the area of the two plates. Fourth one, the separation distance between the plates. The current flowing into or out of a particular capacitor depends on four things. The amount of charge already in the capacitor, the voltage applied to the capacitor by the circuit, any circuit resistance that limits the current flowing in the circuit, the capacitance of the capacitor. Next, what is capacitance? The ability of a capacitor to store charge is called capacitance. that is Q is equal to C into V. The charge is equal to capacitance into voltage. The SI unit of capacitance is coulombs per volt. Next, capacitance is measured in farads. It is the SI unit which is equal to 1 coulomb per volt. The farad is a very large unit of capacitance. A 1 farad capacitor can store 1 coulomb of charge when the voltage across it placed in 1 volt. A capacitor holds 0.02 coulombs of charge when fully charged by a 12 volt battery. A 1 farad is a large amount of capacitance, so the microfarad is frequently used in place of the farad. Next, applications of capacitors. Capacitors have many uses in electronic and electrical systems. Here we see first one, flash capacitor in camera. Most people are now familiar with the digital camera. The flash which comes from the camera when we take photographs is due to the electrical energy released from the capacitor called a flash capacitor. Second one, heart defibrillator. During cardiac arrest, a device called heart defibrillator is used to give a sudden surge of a large amount of electrical energy to the patient's chest to retrieve the normal heart function. It uses a capacitor of 175 microfarad charged to a high voltage of around 2000 volt. Third one, ignition system. Capacitors are used in the ignition system of automobile engines to eliminate sparking. So the capacitors are used to reduce power fluctuations in power supplies and to increase the efficiency of power transmission. Thank you, one and all.